At 0:28 May 17, 1943, over the Möhne Dam, the bomb was already spinning. 60 feet below the Lancaster's belly, a black cylinder roughly the size of an oil drum rotated at 500 revolutions per minute. It had been spinning for the last 12 minutes. The crew could feel the vibration through the airframe. Pilot Officer Les Knight, seated at the controls of a different aircraft further back in the formation, described it later as feeling like flying with a washing machine bolted to the underside of the plane. No one had ever flown into combat carrying something like this. No American bombardier, no Soviet pilot, no Luftwaffe engineer had conceived of it. What the British had built and were now using in live combat over defended Nazi infrastructure in the dead of night was something that shouldn't have worked. Something that most engineers said couldn't work. Something that one man had spent 2 years of his life proving was possible using marbles, a bathtub, and a spinning golf ball. The man's name was Barnes Wallis, and the weapon he had created was about to change the entire concept of strategic bombing. But first, 19 Lancaster bombers had to survive getting there. Wing Commander Guy Gibson led the first wave low over the German countryside at 240 miles per hour, hedge-hopping at 60 feet above the ground. 60 feet. That's not a comfortable altitude. That's rooftop height. At that speed, a power line, a flock of birds, a slight error in judgment, and the plane and its crew of 7 become a fireball in a German field. Gibson's navigator, Torger Harlow, called out terrain features as they came, a constant stream of position checks. The Germans had radar, and they had flak guns positioned all along the likely approach routes into the Ruhr Valley. Flying at low altitude was the only way to stay beneath radar coverage. It had worked so far, they were still alive, but so far only lasts until it doesn't. At 0:15, the first wave crossed into the Ruhr, Germany's industrial heartland. This was the most heavily defended airspace in Europe. Factories, steel mills, railways, refineries. The Germans had been protecting this region since 1939. There were over 100 anti-aircraft batteries in a 50-mile radius. Gibson had been briefed that the approaches to the dams were covered by light flak. What the briefing hadn't fully prepared them for was that the gunners would be waiting. The first burst of tracer fire came from the left, orange and red streaks rising lazily before accelerating to blurs. Sergeant John Pulford, Gibson's flight engineer, spotted it first and called out the bearing. Gibson jinked right without a word. The Lancaster shuddered. The crew didn't speak for a few seconds. Then the intercom crackled and Pulford said simply, "Still here, sir." Still here. That was the standard. This raid, codenamed Operation Chastise, had been in planning since March of 1943, but the weapon itself had been in development since 1941, and it had almost never happened at all. Barnes Wallis was 53 years old and had already built the R-100 airship and the geodesic airframe structure that made the Vickers-Wellington bomber so durable. He was not a man who gave up easily. In 1941, he had begun studying the problem of destroying Germany's major dams, specifically the Möhne, the Eder, and the Sorp, which fed water to millions of people and powered the factories that built the Wehrmacht's tanks, guns, and aircraft. Conventional bombing wouldn't work. He'd done the calculations. A dam wall was too thick, too reinforced, and far too massive to be cracked by a bomb dropped from altitude. The bomb would land, explode, do surface damage, and the dam would stand. The Germans knew this. They weren't particularly worried about their dams. There were torpedo nets in the reservoirs, yes, but those were precautionary. The engineering consensus was clear. Dams were effectively immune to air attack. Wallis disagreed. He'd been studying wave resonance. He understood that a large enough explosion detonated at precisely the right depth and precisely the right distance from the dam wall would generate a shock wave powerful enough to crack the concrete from within. The problem was delivery. You couldn't drop a torpedo. The nets would stop it. You couldn't drop a bomb from high altitude with enough accuracy. So he invented a third option, a bomb that skipped. He had tested the concept first with marbles in his garden, then with a catapult and a tub of water in his back garden, watching how a spinning sphere behaved when it hit a surface at the right angle. The backspin was everything. If the bomb rotated backward at the right speed when it hit the water, it wouldn't sink. It would skip, like a stone thrown by a child on a flat lake, but controlled, predictable, precise. After months of rejected proposals, dismissals from the Air Ministry, and one particularly brutal meeting at which he was told to stop wasting everyone's time, Wallis finally got his chance. A prototype was tested over the Chesil Beach Reservoir in Dorset. It worked. It skipped across the water, struck the target dam wall, and the back rotation pulled it down against the concrete face before it detonated. The bomb didn't need to be perfect. It needed to be precise. There was a difference. 617 Squadron was formed specifically for this mission. 21 crews selected from across Bomber Command. Experienced men, but not told exactly what they were going to do. They trained for 2 months over Welsh reservoirs and the Derwent Water in Derbyshire, practicing low-level night flying and a very specific bomb release procedure. The bomb had to be released at exactly 60 feet altitude, at exactly 220 miles per hour, at exactly 425 yards from the dam wall. Any deviation in any of those 3 numbers and the weapon wouldn't function correctly. To hit 60 feet at night over a lake with no reference points, the engineers rigged up 2 spotlights on each plane, one forward, one aft, angled so that their beams converged on the water's surface at exactly 60 feet. When the 2 circles of light touched, you were at the right height. It was so simple, it was almost embarrassing. And it worked. If you're enjoying this, consider subscribing. This channel covers stories like this every week, stories that never made the headline history books. Lancaster made the first approach. His bomb aimer, Spam Spafford, lay flat in the nose with his face pressed to a simple wooden aiming device, a triangle of wood and a nail. When the nail aligned with the towers at each end of the dam wall, the aircraft was at exactly 425 yards. That was the release point. The bomb dropped. The cylinder, spinning at 500 revolutions per minute, hit the water 425 yards out, skipped once, twice, 3 times, struck the dam wall, slid down the concrete face, and exploded at the preset depth of 30 feet. The dam shook. It did not break, but it cracked. Gibson circled back. The flak guns had found him now. Light cannon shells punched through the wing of a following Lancaster. 2 aircraft made their runs. Both bombs struck. Still the dam held. By this point, 3 aircraft had made their runs. 3 crews had survived the flak gauntlet at 60 feet over a defended lake, and the dam was showing stress fractures but hadn't given way. Gibson did something that wasn't in the operational plan. He flew back and forth parallel to the dam wall during the attack runs of the other aircraft. He called out on the radio to draw the flak gunners' attention to himself. He was pulling fire away from the bombers making their approach. No one had ordered him to do this. He simply did it. The 4th bomb run. The Lancaster of Flight Lieutenant David Maltby came in low, the spotlights kissing the water, bomb away at 425 yards. The cylinder skipped, struck, sank, detonated. This was the decisive blow. The dam didn't just crack, it broke. 134 million tons of water moved all at once. The wall gave way in a section roughly 30 meters wide, and in the space of about 6 seconds, that gap grew to 100 meters as the reservoir emptied itself into the valley below at catastrophic speed. Gibson, circling above, reported later that the water looked dark in the moonlight. A black wave, silent from altitude, moving through the Ruhr Valley with the force of a slow-motion landslide. Villages downstream, Neheim, Wicked, Others were struck within minutes. The wave was up to 10 meters high in places. The second target was the Aider Dam, 80 kilometers to the southeast. The remaining aircraft rerouted. The Aider was harder. The approach was surrounded by hills on 3 sides. The pilots had to dive steeply, level off in time, hit their exact parameters, and then climb hard immediately after release to avoid the terrain. On the first approach, the bomb aimer didn't release. The angle wasn't right. The plane pulled up. On the second approach, same thing. On the third approach, the bomb released cleanly, skipped, hit the wall. 2 more runs followed. The Aider Dam broke open at 1:54. The third dam, the SORP, was a different construction, earth fill rather than concrete. Wallis had warned that the bouncing bomb wasn't optimized for it. He'd been right. The aircraft that reached the SORP dropped their weapons across the crest of the dam wall rather than from the water, causing significant damage but not a full breach. The SORP held. Of the 19 Lancasters that had set out, 8 did not return. 53 men were killed. 3 were captured. On the German side, estimates of civilian deaths in the flood zone have varied over the decades. Current historical consensus places the figure at around 1,600 people, the majority of whom were forced laborers, primarily Ukrainian and Soviet women held in camps in the valley. That detail is not a footnote, it is part of the story. The damage to German industry was real but contested. The Möhne and Aider reservoirs required significant repair. Local power and water infrastructure was disrupted for weeks. German production was affected, though not crippled. Albert Speer organized repair operations that had the basic infrastructure functional again within months. The British had hoped for more, but the weapon itself, the idea itself, had consequences that went far beyond this single night. The principle Wallis had proven, that a spinning, water-skipping bomb could deliver a shaped explosive charge against a target that was otherwise impervious to conventional attack, was a genuine conceptual breakthrough. It required the intersection of fluid dynamics, rotational physics, precision aeronautics, and structural engineering in a way that no other national program had pursued. The Americans had their precision daylight bombing doctrine. The Soviets had their mass attack philosophy. The Germans had their dive bomber accuracy. None of these addressed the specific problem Wallis had identified. What do you do when the target is too tough for anything you currently have? You think differently. You think from the physics backward. You ask, what does the target actually require to be destroyed? And then you build the only thing that can deliver it. Wallis didn't stop there. He went on to design the Tallboy bomb, a 12,000-pound deep penetration weapon that could bury itself 60 feet into the ground before detonating, creating an underground earthquake that collapsed reinforced bunkers from beneath. And after that, the Grand Slam, the 10-ton earthquake bomb, the largest conventional bomb deployed by any nation in the Second World War. Both were used to devastating effect against V-weapon sites, U-boat pens, railway viaducts, and eventually the Tirpitz, the German battleship that had survived every previous attack. One Tallboy hit was enough. The same mine that tested bouncing marbles in a garden bathtub in 1941 designed the weapon that sank Germany's most powerful warship in 1944. Barnes Wallis received no knighthood until 1968. He spent the post-war years largely in the shadow of other figures. Bader, Gibson, Cheshire. He kept working. He drew designs for variable sweep aircraft that influenced the F-111 and the Tornado. He wrote proposals for a supersonic commercial airliner 30 years before Concorde flew. He was the kind of man who simply couldn't stop solving problems, because to him the gap between what existed and what was needed was always visible, always obvious, always worth addressing. He also never forgot the men who flew his weapon on the night of May 16th to 17th, 1943. He met many of their families after the war. He kept correspondence with survivors for the rest of his life. When the film The Dam Busters was released in 1955, he reportedly wept during the scenes depicting the losses. 53 men. He knew some of their names. He had watched the test runs. He had shaken their hands. The bouncing bomb was never used operationally again after Operation Chastise. It was a weapon built for a specific purpose, used once and retired. The remaining weapons were destroyed or locked in storage. The design remained classified for years. What it left behind, though, was not a weapon. It was a proof. That one engineer, with 2 years, a bathtub, and the stubbornness to keep going after every rejection, could give 19 crews a tool precise enough to crack something the entire conventional wisdom of military engineering had declared unbreakable. The Germans never cracked it. The Americans never tried. The Soviets never pursued it. Not because they lacked engineers. They had brilliant ones. But because none of them had a Barnes Wallis who looked at a dam and asked, not, can we bomb it, but what would it actually take? That question is the invention. The bomb was just the answer.